Okay, you already learned to measure the outside of two-dimensional shapes. So perimeters on polygons, and either circumference or arc length on circles. Okay, so now we're going to talk about measuring the inside of two-dimensional figures. Now the outside, perimeter, circumference, or arc length. But when you're measuring the inside of a two-dimensional shape, that's called area. Okay, so think about it kind of like a yard. If you had a fence around the yard, okay, so the fence would be the perimeter, and then the grass, the dirt, the flat part on the bottom on the inside of maybe that rectangular yard, that would be your area. Okay, so we're going to talk about a few shapes today, and then next time we'll talk about a few more shapes. Okay, this is kind of the way it starts when you're teaching elementary school. Okay, so again, let me go get that PowerPoint. Okay, and we're going to kind of start off talking about parallelograms, but remember, rectangles and squares are also parallelograms in area. Now, let me tell you how I would kind of do it if it were me and I was the elementary teacher. I'd probably come in and go, okay, today we're going to talk about the measure of the inside of a flat surface, and ask a student who can remind me what that's called, and hopefully they'll say area, okay? Because remember, earlier, you can even do area in kindergarten, but they're not going to measure it in like the units. They would measure in non-standard units. You might give them a flat picture and give them like Skittles and tell them to figure out how many Skittles it takes to fill in that shape. Okay, but now think about it. If it took them 10 Skittles and then you made them take the Skittles off of the bunny, if it were Easter, or the square, and fill it in with cheese nips, would it take more or less than 10? All right, do you see that it would take less because the thing you're measuring with is bigger? A cheese nip's bigger than a Skittle, so it would take less cheese nips. So if it took, 10 Skittles, it might only take like 4 and a little bit more cheese nips. Okay, so they should already know kind of what area is with non-standard units. Okay, they measure the inside of a two-dimensional or a flat picture. So I might cut out, maybe, for instance, usually they start with rectangles. I might cut out rectangles of all different sizes out of graph paper, okay? And then maybe put, 3 or 4 of those in a Ziploc bag and give every child a Ziploc bag with their, 5 rectangles in it. And tell them that I want them to measure the inside of their rectangle. They can do it any way they want to, okay? They can go get rulers or protractors or a compass off the table, or, I guess you could just count the squares and write that down. Now, this is why you kind of take Ed Psych. You want to kind of use, their own laziness kind of against them. Because most of them, they're just going to count the squares because that's easy. All right, so look what they would be looking at. Now, I'm kind of jumping ahead a little bit, okay? But they would have like, a rectangle, squares are rectangles, so they would have shapes. So here they would count, they've got 1, 2, 3, 4, 5, 6, 7, 8. So they've got 8 squares. And over here, if they counted, 8 here and 8 more and 8 more, they ended up getting 64 squares. Now, they do that over and over and over. Now, what always happens when I've done this is after just a few minutes, somebody raises their hand and they go, Dr. King, come here. I walk over there and go, what? And they go, well, I think I found a shortcut. And you go, no, what? And they go, watch. If you count 2 this way, and there's 4 this way, and 2 times 4 is 8. And then over here, if you counted 8 this way and 8 this way, 8 times 8 is 64. Well, that always works. And you're like, oh, I don't know. Try it. Now, do you think all those kids are going to figure that out? Bless their baby hearts. Some child will be counting those little squares till the end, okay? But that's why you make the big bucks, okay? So, when everybody's finished, you might want to say, John, what'd you get for number 1? 8 squares. Sarah, what'd you get for number 2? Well, I got 64 squares. You would just check all the answers first. And then you're the teacher, so you get to decide. You might pick the first kid that figured it out, or if there's a child that's never figured anything out in his whole life and he's figured this out, you might call on him. And you go, well, John, tell me what, tell everybody what you told me. And he goes, well, if you count this way across, there's 4, and this way is 2, and 2 times 4 is 8, and it always works. And you're like, oh my goodness. Everybody's going, I figured that out too. And you're like, so y'all are telling me if you just count how, and they're going to start yelling out things like long something is. Now, usually they'll say how tall, but you know, you're going, so how, and they're in a frenzy. So they'll just agree. So how wide? Yeah, how wide? So you're telling me if I just say how long something is times how wide something is, that would work every time? Yes. Well, I guess if you want to, you could just put L and W. So do you see then they figured out the formula for area of a rectangle is just length times width? So that's kind of inductive teaching. Rather than just coming in and giving them a formula, that's deductive teaching. And you can't teach everything inductively, but when you can, do it. Because if they come up with a formula themselves, they're going to remember it better. Okay, so your formula for a rectangle is just length times width. And it doesn't matter whether you call this the length or this the width. Okay, now for a square, because the sides are all the same, you could do length times width, but the length and width are always going to be the same number. So sometimes instead of saying length times width, they'll just say a side times itself, and a side times a side is side squared. Okay, but you understand that the formula for a rectangle would also work on a square. How long something is times how wide something is. Okay, now, but notice what you get free of charge by doing it this way. The kids literally see that there are squares. There are literally squares in there. Okay, so I really like this idea that they can figure that out. Now, so when you're doing area, you're always going to have square units. So it wouldn't be like 8 feet, it would be 8 square feet. Okay. But now remember, what does a square foot mean? It literally means you have a square that's 1 foot long and 1 foot wide. That's what a square foot is. So if you had 8 square feet, you'd have 8 of those squares. Now, they'd be different than 8 square inches. That'd also be 8 squares, but they would be like 1 inch long and 1 inch wide instead of 1 foot long and 1 foot wide. So make sure that they can do that. Now, I want you to try this. I want you to read this problem. I'm going to read it to you, and then I want you to pause the video and go get the answer that you would get. Don't cheat. Okay. Suppose you had to carpet a room. Suppose you wanted to carpet a room in your house, and it was 10 feet long and 8 feet wide. Okay. So remember, the carpet will be the inside, so that's area. So you go to a store called Carpet Design and you want to buy the carpet, okay, but they only sell that carpet in square yards, not square feet. So I want you to figure out how much carpet you would need and the cost. So remember, your room is rectangular. We're saying it's a rectangular room. So you find me the area of that rectangle, okay, and you're going to get it in square feet, but you get to the store and they want square yards. So you change your answer for square feet to square yards, and then every one of those square yards is going to cost you $32. So you figure out how much it's going to cost to carpet your room, and after you got that answer, then resume the video. Okay? I trust you. All right. Now, let me show you what some of you may have done that you weren't thinking about. You got 80 square feet, right? And you may have divided by 3, but look why that's not going to be right. Okay? Do you see that this is a square yard? So it's a yard long and a yard wide. Okay, so the big square is 1 square yard. But look, a yard, remember, is 3 feet. So it's 3 feet all the way across. So that'd mean that would be like 1 foot, that'd be a foot, and that'd be a foot. And the same thing here. So look what that means. This little square is a square foot because it's a foot wide and a foot long. But look, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 square feet in a square yard. So look at the problem. You found 10 feet times 8 feet was 80 square feet. Then some of you may have, when I told you to change the square yard, you may have divided by 3 and you get a little more than 26, but they're not going to sell you part of a square, you know, of carpet. So you'd have to round up to 27, and then you'd go to the store and buy, I need 27 square yards times $32 would be this much before tax. But look what you should have done. All right. You should have divided by 9, not 3, because there are 9 square feet in a square yard. So you should have been ordering 9 square yards times your $32 would have been $288. So do you see how much money you wasted? You wasted almost $600. Oh my word, and you're a teacher? Not good. It's going to be, you're going to be poor. Okay. So let's go talk about what we should have done. Okay. Let's change this and get my pointer back. Okay. And go to the next slide. Maybe. All right. There we go. Now let's talk about how to work the problems. All right. Areas measured in square units. So square yards are a yard long and a yard wide, square feet, foot long, foot wide, and so forth. This is the easiest way to do it. Okay, so you don't have to memorize a whole new bunch of conversion factors. You're going to do it exactly the same way you did with linear units with one extra step. Now look, I'm changing 3 square yards to square feet. Now, the same thing is true before. Big to small, you multiply. Small to big, you divide. So yards to feet is big to small, so you multiply. Okay. Now remember, how many regular feet are in a yard? 3. But if the units are squared, you have to square the conversion factor. Now look what you're going to do though. You've got to do 3 times 3 squared, but you got to do order of operations. So remember, we do exponents before we multiply. So when you do your exponent, 3 squared is 9, and then 3 times 9 is where I got the 27. All right, look right here. Now remember, you're not going feet to inches, you're going inches to feet because you're going number to blank. Okay, so inches to feet is small to big, so that's why I divided. Now, how many plain inches are in a plain foot? Like on the old worksheet, just 12. But if your units are squared, you've got to square your conversion factor. And what do you do first? Do you divide or do you exponents? Remember, parenthesis, exponents, multiplication, division, and then addition, subtraction. So 12 squared is 144. So I take 360 and divide by 144, not 12, and I get 2 5/10. Similarly here, a metric system's the same way. Big to small, you multiply. How many centimeters are in a meter? Remember, they're 2 steps apart, so that's 100. But if the centimeters are squared, the conversion factor is squared, and 100 times 100 is 10,000. So if you take 32 thousandths and multiply by 10,000, you get 320. Same thing here, from hectometer to kilometer is small to big, so we divide. There are 10 hectometers in a kilometer, but I've got to square that 10 first. So I'm dividing by 100, I'm not dividing by 10. Remember, when you divide by 100, it moves that decimal 2 places to the left. Remember, when there's not one showing, it starts at the end. So I'm going to give you some problems like this to work where you're converting in square units to make sure that that's okay. Now let's go to some formulas. All right, parallelogram. Now notice a parallelogram, we go from what we know to what we don't know. We know how to do a rectangle. Remember, that was length times width. Okay, but remember, if you wanted to know length times width, you couldn't use that length because it's slanted. You wouldn't want, if you want to measure how tall something is, you got to make sure your ruler's not slanted, it's straight up and down. Remember, the math word for straight up and down is perpendicular. Okay, so what you could do is you could take some scissors and cut this triangle off. So they cut it off and then move it over here. So they moved it over here, and then that turns it into a rectangle. Now you know how to find the area of a rectangle. The area of a rectangle is length times width. But your width was what we call height up here. Now remember this, if this is B, the side across from it is B. So this whole length up here would be B times your height. So your formula for a parallelogram, they don't say length times width, they say base times height. Okay, now just remember, anytime in the formulas when we're doing area that you see B's and H's, you have to have a right angle. Bases and heights have to be perpendicular to each other. Now think about it. On a rectangle, isn't a rectangle a parallelogram? So actually, instead of memorizing 3 formulas, length times width for a rectangle, and side squared for a square, and the side squared for a square, and then parallelograms base times height, actually this base times height would work for all of those. And again, that depends on what your kids have to learn. If they have to memorize a formula to recognize it on a test, then they need to memorize all 3 formulas. But if they just need to get the answer to the area, they can just use base times height for rectangles and squares and parallelograms. Okay, so look at this example. What's the area of this parallelogram? Now, do we understand? Don't get area confused with perimeter. So remember what I told you, you got to have straight up and down. So do you see that the base is going to be 10 and the height would be 6, not 8? Okay, so the area of this parallelogram would be base 10 times height 6. So 10 times 6 is 60, but it would be square centimeters, okay, not just centimeters. Now, what if you were doing perimeter? Well, perimeter would be 8 plus 10 plus another 8 plus another 10. Okay, so we understand we get 36 centimeters for the perimeter. So don't get those 2 things confused. All right, look at this one. All right, what's the perimeter and what's the area of this one? Now remember, for area, you've got to find the right angle. That's how you find the base and the height. So this right angle is where this segment intersects that one. So these are the 2 measures. This will be my base and this would be my height. So if I wanted the area, I'd have to say 2 5/10 times 1 8/10. And then that answer would be square meters. But if I wanted the perimeter, I would add up a 2 and a 2 5/10 and another 2 and another 2 5/10. So I ended up getting like 9 meters. So remember, it's plain linear units for perimeter and square units for area. Okay, is that making sense to you? Okay. All right, so let's look at another real quick. Okay, I don't want to keep you long. What about a triangle? Now, look what would happen if you took a triangle. If I were teaching kids again, what I would do is I would make them draw a triangle and then make another one just like it. You know, they could basically just trace the one they have and cut out 2 congruent triangles. Now, if you flip this one and rotate it and put it together, do you see that you get a parallelogram? No matter what kind of triangle you had, right triangle, isosceles, when you put 2 of them and you put them together, you're going to get a parallelogram. Now remember, you know how to find the area of a parallelogram. It's base times height. But instead of wanting the whole thing, I just want this. So do you see that one of these triangles, because it takes 2 to make the parallelogram, so one of them would be half of that. Okay, so what do you think the formula is going to be for the area of a triangle? Yeah, you're so smart. I knew you'd think of it. All right, so your triangle area is going to be half of your base times your height. But just like before, anytime it's base and height, you have to have a right angle. And on your test, I will draw a right angle. Okay, so my base is 6 centimeters and my height is 4 centimeters. So 6 times 4 is 24 and half of 24 is 12. Now, don't say 12 centimeters squared. That's pronounced 12 square centimeters. Okay, so a lot of times with kids, instead of letting them put this, I would really make them write 12 and the word square and the word centimeter so that they pronounced it correctly. So 12 square centimeters, because I want them to understand, if you were to fill this thing up, it's hard to see on the video, but they're little squares. It would take exactly 12 of those squares to fill in that triangle. Okay. All right. So let's look right here and make sure we're good one more time. So do you understand, if I wanted area, I've got to find my base and my height. So if I've got an acute triangle, the height's going to be on the inside. See, I would do the 11 times the 4 and get 44 square inches for this area. Okay, if you've got a right triangle, see, the height is actually going to be one of the sides. That right angle is where that 12 and that 5 meet. So I would say 5 times 12 and get 60 square feet. there, okay? Now, on an isosceles triangle, the height is a lot of times outside, okay? So from the tallest point down to the lowest point is 8 centimeters. So this area will be my base, 12, times my height, 8, and 12 times 8, I'd get 96 square centimeters, okay? Now, if I wanted perimeter, though, remember I would just add the 5 and the 13 and the 12 and get basically my 30 feet. Over here, I'd add the 6 and the 8 and the 11 to get my perimeter, okay? And get my 25 inches. And here, I would be adding for perimeter my 10, my 15, and my 12. So, you know, you don't want to get those two things confused, okay? All right, so that's how we do area of triangles and parallelograms and rectangles and squares. All right, so go try that homework. And again, just like before, if you have any trouble with it, just make sure that you let me know, okay? And the next video, I'll be talking about some area of some other things, okay?